In the last talk, we were discussing this notion of technology as a source of beauty. How could you merge physical considerations and issues of form and maybe make them reinforce each other? And we're talking about how that might occur. In the talk today, we're looking at some buildings, some projects that really exemplify that. And I hope you'll be blown away by how beautiful they are, how delightful they are, to use Vitruvius's word, and that delight really does come from, again, using Vitruvius's word, this notion of their firmness or their technology. So we're talking about firmness and delight. In the last talk, we introduced this guy, Santiago Calatrava, and I want to focus on a few of his buildings at the beginning of this talk. He's a guy who had both an engineering background and an architecture background and was making very, very beautiful things, but coming very much out of technology. So the beginning of his practice really substantially was him making bridges. Because he was an engineer, he tended to get these commissions for bridges. So this was early in his career. He did a bridge in Barcelona. There was a pedestrian bridge and a vehicular bridge, and this beautiful representation of the two different functions, one kind of scale and structural element for the pedestrian bridge, another one on the other side, and then the two of them really supporting the car space in between. And all of that then working with the movement of people down the quays and up the stairs and across the pedestrian bridge. But again, I think making a really beautiful object out of what really was just a bridge. Then he began to take it even much further. This one is stunning. This is the Alamillo Bridge in Sevilla in Spain. This was for the, I think, 1992-93 World's Fair in Sevilla. And this was kind of the gateway to the whole World's Fair site. So they wanted a very dramatic, very beautiful bridge there. And he's thinking exactly of how does this stand up, about its firmness. And he's using this heavy piece of concrete, which wants to pull down like that. Gravity pulls it down. And he's using these cables in tension to then hold up the bridge, which is right there. So it's the natural weight of that pulling down that counterbalances the weight of the bridge over here, and just those simple steel tension bars holding it up. Dramatic and beautiful, all of those things we talked about in the last talk. Economy, complexity, potency, really making this spectacular bridge. This is maybe one of his most famous bridges. It's a bridge in Bilbao. This one is just down the river from Frank Gehry's Guggenheim Museum in Bilbao. It was an area where you tended to walk down here, turn around, and walk back to downtown this way. So the whole bridge kind of gestures that way to begin to make a loop. And it really is the cantilever of the concrete that we're seeing here, that movement around and back down to downtown in the other direction. And then every element of it, the ribs, the struts, the supports, all of that exposed, and using the mirrored surface of the river to reflect that as you go by. And then this arch that is holding the bridge up, now not a simple arch, a complex arch, the complex curve of the bridge kind of counterbalanced by a complex curve of the arch. And in the end, making something that is a simple economical structure, but with incredible complexity and potency and beauty. Now, there are many of you, I'm sure, that know this bridge in Dallas. There actually are two bridges done by Santiago Calatrava recently. the Margaret Hunt Hill Bridge that he did first, which is just this great arch within this incredibly complex web of tension members that are holding up the roadway there. And then very recently completed the Margaret McDermott Bridge just down the Trinity River a little further. And in some ways, like the bridge we saw in Barcelona with a pedestrian walkway on either side and then a massive car bridge in between. So maybe you think, well, that's natural. This is, bridges can be very beautiful if their technology is expressed in a very sophisticated way, as Calatrava is doing. But Calatrava has also really taken that same idea into making buildings and using those same notions of how a building is built and the bones and the skin and the web and the structure of the building as a way to make this really beautiful object. This is the Milwaukee Art Museum he did in 2000. It's right on Lake Michigan there. Milwaukee is a Rust Belt city. They were very, very strong in technology. They were a manufacturing city. They had great craftsmen. They had great engineers. And they made very sophisticated industrial production. And then, you know, a couple of decades ago, all that started being outsourced to other countries. And Milwaukee has had an economy that really faltered in that period. But in 2000, when this one was done, they were ready to show maybe the last gasp of what we're able to do with technology. And they hired Santiago Calatrava to do a design that would demonstrate the technological capability, the manufacturing capability of that culture and how that might express itself in an art museum. And out of that came this Milwaukee Art Museum. So from the city, you kind of enter at an upper level here. Like many cities, they'd put a freeway adjacent to the water, which kind of cut the city off from the water. Calatrava is making a bridge that goes over the freeway and then connects the art museum directly into downtown. He's also connecting over to the old art museum here, which was a building that was done by Eero Saarinen, somebody we've looked at a good bit before. That was done in the 1960s. So it's plugging into the Saarinen Art Museum there. It's plugging into downtown there via this bridge. So from downtown, you see right across, and that becomes a kind of piece of sculpture, just like this piece of sculpture that announces the bridge to the museum there. And that experience of moving across the bridge is as much a part of the museum as the building itself, and really almost makes the freeway kind of cool. Once you're over it and you see this again, it's like a little bit like the Alamillo Bridge, where it's got this strut, but now there are tension members going down and tension members going across and holding up that little delicate pedestrian bridge going over the freeway. And there is a whole bottom of the building that almost becomes an extension of the earth around the lake, this kind of bank of the lake that gets extruded up in kind of curvy forms, and it's made out of concrete, like the kind of earthen forms at the edge of the water there, so that becomes a base made out of this fluid kind of concrete. We looked last talk, Le Corbusier acknowledging the kind of fluidity of concrete as this liquid that's kind of shown here. And then there are beautiful views out from below this cantilevered reinforced concrete piece. That's a little restaurant. You get views out to Lake Michigan. Under there is also a parking garage so that it buries all of that part of the building that might not be so scenic. And then on top of that is this kind of bird-like structure, this light, delicate steel structure, very different in character from the concrete structure, but kind of soaring above it. And the really cool thing about that is it actually moves. So this is sunshade right there. Here we're seeing it kind of all locked down. Here it's beginning to open up a little bit. There it's opened a little more and a little more. And finally, there it's completely open. So they actually move this up and down at various times of the day. And it's very dramatic. They play music, and it's almost a little corny, but it's impressive. It's potent. This kind of bird flapping its wings that actually is a sunshade. It actually is doing a job, and at different times of the year and different times of the month and day, they will close that down or open it up, or depending on what kind of exhibit they have inside and how much light they can stand or not stand, they open or close those sunshades. So very functional part of the building, but at the same time very lyrical and beautiful. And every detail of how the building's put together, you can see that study of bones and study of joints and study of botanical objects that have inspired understanding how you make technology and the making of a building begin to make this beautiful object. And they really did use local craftsmen and people who were able to do machining and able to do very sophisticated making of things to craft this very beautiful art building. And then inside there are these soaring spaces. This is with the sunshade creating a dappled light on the bottom there. And that very different light quality depending on how you open or shut the sunshades up above. And throughout the whole museum, it's always about these structural members that are beautifully shaped to make very elegant and organic forms in the building. Now, to me, this is firmness and delight. This is structure, materials, technology, creating something that's really very, very beautiful and very lyrical. You can certainly see the similarity between the Milwaukee Art Museum he did in 2000, and 16 years later he completed the Oculus, which is a major landmark building in New York City. This is on the site of the old World Trade Center. And the World Trade Center was always a confluence of subway lines. There was the PATH train, which is a regional fast train, and there were all the subway lines that came in there. When the World Trade Center buildings went down, also all the underground subway system got destroyed. So all that got redone, and this is the major train station for entry to all of those underground lines of subway and train below the World Trade Center site. So now that all that site is completed, the building is very much a landmark there. It's where you come and go to transportation to the rest of the city. But like many train stations, it also, as a function, it has a lot of retail, has a lot of stores and shops and places to be, as well as just a train station. But those ribs and the sunshades and the structure that holds the building up, very, very beautiful. Just the logical, regular, kind of inevitable rhythms of structure are definitely lovely. And in the daytime or at night, when it just glows and becomes a real landmark in the district. And then when you go inside, it's a spectacular space inside. There are shops at 2 levels all the way around here. It's thousands of people coming and going to their trains and to various other places in the city. It has become immediately a major, major landmark in the city, and also a place where people meet and gather and go and hang out, a real destination point as well. And I gotta say, it blows you away. The scale is spectacular. The kind of brightness and whiteness you can see. That when I was there this time, it was freezing cold and wintertime, and it had been a horrible gray day. But man, the feeling inside there was spectacular and bright and cheery and wonderful, and everybody was taking full advantage. It was just mobbed with people. And then as you go to the quays for the trains and to the subway, instead of dark, squirrely little passageways, it really is taking all of the structural system that's required underground to make all this work and making it very beautiful and very, very bright and light and cheerful. So that's the technology of Santiago Calatrava, technology that creates this beautiful architectural form. But I want to make it clear, there are many ways to do this, and it may not just be the technology of structure. It may not just be the technology of concrete or steel. The next project I want us to look at is actually all about glass. So this was an interesting situation where in Toledo, Ohio, which was another one of those Rust Belt cities, but in this case, one of the things they produced a lot of in Toledo was glass. It was a real center for glass production in the United States. And the art museum, because that was an important thing for the economy of their region, they actually acquired a very large collection of art glass. So they had always had as a strength of their art museum this collection of art glass. So they decided to build a whole new building that would house that collection. And the new building was decided to make it out of glass. So the architect for this is Kazuo Seijima. Her firm is Sana. And we've looked at several projects she's done before. The design school in Zollverein in Germany. And we also looked at the museum that she did in Kanazawa in Japan. She's a Japanese architect, one of the most phenomenal international architects currently. She did this in 2006. And it is really looking at the technology of glass. Everything in the building is glass. Exterior walls are glass, interior partitions are glass, and you kind of have to understand glass to understand how amazingly daring a lot of this is. But she's curving the glass constantly. She's using enormous sheets of glass. There are no mullions in the glass, no dividers there. It's just glass. And often the glass is being used structurally so that it's actually doing a structural job. But the entire building is about exploring the technology of glass and what is glass capable of doing. And it makes this beautiful transparency and layers of glass. Sometimes even when she needs more acoustical treatment, she'll make a double layer of glass, 2 walls of glass next to each other to kind of keep the acoustics of the lecture hall from the area around it. The glass, of course, connecting you to the site, which is a beautiful, soft green park, actually across the street from the rest of the museum, but in this beautiful park. And then just always using the glass in the most sumptuous and thorough way she possibly can. Now, it's interesting that in the museum, they actually have a little glass blowing studio. So they demonstrate the technology of glass. This is how glass is when it's molten and it's liquid. This is how glass is when it cools. They're explaining the technology. And in an art museum, wow, that's kind of a unique thing, where the art museum is saying that to understand the art of glass, you kind of have to understand how it's made. What is the technology of glass? And especially in the city where they were making glass, and that's very much a part of their culture there. So in the museum, there is a demonstration room where they show you how to fire the glass and how to blow the glass and how it's made. And the building itself is demonstrating that same kind of technology in the walls and the supports and the rooms and the interior and the exterior and the transparency and the connection to the gardens, all of those things in the building as well. So you're seeing these art objects in glass, and you're seeing the building very much made of glass as well. So a spectacular example of taking a unique situation and saying, I'm going to let the technology sing. I'm going to really take this material, explore it in a very sophisticated way, craft it very carefully, use economy and complexity and potency to make a very beautiful building out of glass. A third architect I want us to look at here, Calatrava is working in steel and concrete. Sejima is working in glass. This third architect is Diller, Scofidio, and Renfro. Liz Diller is often the spokesperson for this building. I've heard her give a lecture on this building. Spectacular building that is also generated very much by the technology of how the building is put together. So it is made of a very interesting and very new technology. She is breaking new ground here. So this is made of what's called GFRC. It's glass reinforced fiber, GFRC, glass fiber reinforced concrete. Could we go back and not make that quite so stumbly? Pretty much the whole building is made of GFRC, glass fiber reinforced concrete. Now this is a relatively new technology and it allows the concrete to be much, much stronger than normal concrete is because it's got these glass fibers reinforcing it. So that means that the concrete is not these big chunky things. It's not this heavy, massive material. Instead, you can make smaller doses of concrete that have the strength that used to be in much larger, chunkier doses of concrete. So the GFRC is a new technology of concrete. And then in addition to that, she's making the molds for these pieces out of CNC technology. So it's really digital fabrication technology. And she's using mass customization. So you're able to use a computer to generate a lot of variations and a lot of options that if you had to sit and draw every one of those yourself, it would be impossible. And if you had to sit there and manufacture each one of those themselves, it would be impossible. But because of digital technology, you're able to really let the computer systems do some of that work for you, both in the design and in the manufacturing side of it. So they're making the molds out of CNC technology and CAD/CAM, computer-aided design, computer-aided fabrication. And then they're using this technology of the glass fiber reinforced concrete. Really, all of those recently developed technologies to do something that would not have been possible 25 years ago, but is now possible. And what she's doing is making this very elaborate skin. And in a way, it looks like it's a kind of repeated precast GFRC element. But in fact, there's tremendous customization from one piece to the next, to the next, to the next. There you can see in the way the glass is slivered in there, but also just the geometry of each of the pieces. Often warps and twists. When it gets to a corner, it's making a lot of different shapes. So there are many circumstantial elements that are making different pieces very unique and customized. That whole ensemble there, of course, is interrupting an otherwise fairly regular pattern. The lift that's happening here interrupts those and makes a lot of unique pieces. But it's using this ability of digital technology to find a normative version and then to make many, many, many customized pieces away from it, but to do it in a fairly economical way because of this computerized fabrication. So that is creating this beautiful, rhythmic, and very delicate skin. If that had been in regular concrete, it would have been very clunky. In the GFRC, it's much more thin and delicate and elegant. So it's really, again, taking this brand new developing technology and using it as a springboard for the very lovely skin of that building. Now, there actually are two different pieces of the building. In the lecture I saw Liz deliver, there is what she called the vault, which is this very solid piece anchored into the ground. And they have a very large collection that's not always on display. So there's a vault down there. And there also are a few display spaces that are very, very closed and dark and completely controlled light. So there's a vault at the bottom of the building. And then there's a veil that is this delicate GFRC skin that's around the outside. So we're seeing the vault on the left, and we're seeing the veil kind of tip itself up at the corner and allow entry into it. But it is that interaction between the vault and the veil that gives some of the real dynamism to the building on the inside. So here we're seeing the vault, these tunnel-like, very solid spaces, and these storage areas for the art that is not on display there. And then from that vault, you take this escalator up into the building, and you emerge above the vault and in this area that is defined by the veil. And the veil is letting little dribs and drabs of light in, tiny little doses of indirect light, which is not damaging any of the art, but allows this even glow of light inside the art museum, which feels so bright and clean and open, and like there is natural light in there, but is protecting all the paintings and the sculpture and the very vulnerable art that's on the inside. But that veil, again, inside and outside, is something that would not have been possible without this new technology, and the architect is using that technology, just exercising it as thoroughly as possible. So in these three instances, we've seen Santiago Calatrava using technology of steel and concrete to inspire a beautiful place like the Oculus. We see the technology of glass explored thoroughly and stretching it and advancing it and using it in the most sophisticated, well-crafted way in Sejima's Art Museum, Glass Pavilion in Toledo. And then this new technology of glass fiber reinforced concrete and CNC molds and all of that really generating a technology in the Broad Art Museum in Los Angeles. Again, all of them taking one piece of this course, physical considerations, merging it with another piece of this course, form, and seeing how firmness can really create delight. Okay, see you next time.